observing the waveforms, output waveforms of the single phase half wave controlled converter. Here you are observing that we can control the firing angle alpha and we can control the output voltage V0 and output current I0. Now let us try to verify it mathematically. We can derive the expression for average DC voltage the same way which we did in case of uncontrolled rectifier. So average DC voltage is nothing but an integration over a period 1 to 2 pi. So output voltage VO DC can be taken as it is equals VO, output voltage VO equals to VDC. So we had discussed about the waveforms of single phase half wave control converters output. You observed that the output voltage is available only during the positive cycle when the gate signal is applied. Means output voltage can be controlled by controlling the firing angle alpha, and the same way output current also can be controlled. Now let us try to find out the value of this DC, that is nothing but average DC value. So average DC value can be calculated by taking integration of output voltage over the period to 2 pi, because same cycle is going to be repeated after every 2 pi. Now if we concentrate on the output voltage waveforms, you will find that the output voltage is available only from the cycle alpha to 2 pi. So I can change the integration limit from 1 to 2 pi to alpha to pi, because from 0 to alpha the output voltage is 0, and from pi to 2 pi again output voltage is 0. So if I substitute this into equation, my equation will become VDC will be equals to 1 upon 2 pi integration over alpha to pi Vm sin omega t d omega t. Now if I solve this integration, I'll get an equation that is output voltage VDC can be given as Vm by twice pi into 1 plus cos alpha. You can find here that output voltage VO, otherwise VDC, can be given as Vm upon twice pi into 1 plus cos alpha, where alpha is a firing angle and which can be controlled by controlling the gate signal. Now let us try to get the two extreme conditions, alpha is equals to 0 and alpha is equals to 180 degree. Now when I substitute value of alpha is equals to 0, I will be getting maximum voltage. Alpha is equals to 0, let us substitute value of alpha is equals to 0 in the equation. Vm upon twice pi 1 plus cos alpha, cos 0 will be equals to 1, and the output voltage, maximum output voltage which is possible in case of single phase half wave control converter is Vm by pi, which is similar to that of your uncontrolled rectifier. Whereas as I go on varying the value of alpha, my output voltage, as I slowly and steadily go on increasing the value of alpha, you will find that you can substitute value of alpha is equals to 45 and you can calculate the output voltage. You can substitute the value of alpha is equals to 90 and again you can calculate the output voltage. Now when I substitute alpha is equals to 180 degree, I will get that output voltage will be equals to 0. So I can conclude that in case of single phase half wave controlled converter, I can get an output voltage from Vm by pi to 0. Means the voltage which is available from 0 volt to Vm by pi. So maximum voltage which is available is Vm by pi and minimum voltage which is available is 0, and the output voltage totally depends upon value of alpha as you had seen it mathematically. On the similar basis, I can derive the expression for root mean square voltage. DC voltage is nothing but an average DC value, VDC, whereas RMS is nothing but the average AC value. In many of the applications or in many of the cases, if your positive and negative cycle is symmetric towards positive and negative, then the average DC value may be 0 but not RMS value. So RMS value is nothing but root mean square. So square is taken and again root of that is taken. So by substituting again the same, that is VO is equals to Vm sin omega t over the period alpha to pi, and 0 for 0 to alpha and pi to 2 pi. You can substitute the value into the equation and you can get the equation for a root mean square value by the method which is shown here, by simply solving the integration which you have studied. Okay, and now we have studied the operation of single phase half wave controlled converter in case of resistive load. Let us try to see what happens if load changes from resistive to inductive, because many of the applications the load is inductive. We can assume for a resistive load in case of real-time applications. So study using inductive load is essential. Now, in case of inductive load, if it is an uncontrolled rectifier, when anode goes negative with respect to cathode, automatically diode to go to reverse bias, and which is allowing the current in another direction. But in case of thyristor, let us concentrate this concept carefully. When the diode turns on, when it turns off, and second case is when it turns on and when it turns off. In case of uncontrolled rectifier, that is in case of diode, when anode is positive with respect to cathode, the voltage greater than the knee voltage, that is 0.10, 0.7 silicon and germanium respectively, I will go forward bias. And when anode is negative with respect to load, it goes reverse bias and will be acting as a off switch. So only bias applied is converting diode from off to on state as well as from on state off state. But in some silicon controlled rectifiers, it's the NPN structure, as I told you. It is not essential that only applied forward bias will turn the device to on state from off state. Now, in case of turning on, what is essential requirements in case of SCR are? Anode must be positive with respect to cathode, and the appropriate gate signal must be applied across gate terminal. Then and then only it is going to turn on. That is what we discussed in case of resistive load operation. So it is turning on. Now let us concentrate on turning off. As I told you, SCR will turn off when the current flowing through it reduces below the amount called as an holding current. If current is above holding current, it will be in on state. Now let us focus on a load type. If load is resistive, the voltage waveforms will follow the current waveforms. There is no leading and lagging concept between voltage and current. Both will be identical, will be same in the shape. So as voltage passes through zero, current also passes through zero, and because of line commutation, SCR turns off. As resistance does not contain any charge across it, it does not store any charge across it. But when load is inductive, it will store some charge during the forward bias, while as it will retain it when the voltage reverses, and it may keep thyristor on even after phase reversal of the voltage. That is what happens in case of inductive load.